Limitation of zero IF receiver. The receiver of simple CW radar from above figure is in some respects analogs in super heterodyne receiver. Receiver of these types are called homodyne receivers or super heterodyne receivers with zero IFs. So the simple receiver is not very sensitive because of increasing noise at the lower intermediate frequency caused by the flicker effect. So the flicker effect noise occurs in semiconductor device such as crystal diodes and cathode of vacuum tubes. So this reduces the sensitivity. The local oscillator generates a noise. This noise is called flicker. It varies as 1 by f alpha, where alpha is approximately unity. If flicker f is equals to the flicker noise is large. That contrast to the short noise or thermal noise which independent to the frequency. So this is the block diagram of CW radar. So CW radar consists of with non-zero IF, CW transmitter, mixer, sideband filter, mixer to IF amplifier, detector, Doppler amplifier and indicator. So here the flicker noise is generated at low frequency range in which generally CW radar operates on flicker noise considerable. So to remove the flicker noise we use the super heterodyne receiver which is used as IF have high enough. The small portion of transmitter signal is mixed with the local oscillator and IF is generated in two sidebands, that is F0 plus F of IF and F0 minus F of IF along with F0. Higher harmonics filter selects the one of the sideband signal for as a reference signal. So we are getting that F0 plus or minus FD, F0 plus or minus F of IF. So F0 plus or minus FD minus F0 plus or minus FID gives the F of IF plus or minus FD. The reference signal from the sideband filter is mixed with the signal from the receiving antenna to get the intermediate frequency. So this F of IF plus FD is amplified and then applied to the second detector to the Doppler echo signal. The Doppler amplifier amplifies the Doppler echo signal so that it can be indicated in device such as frequency meter or earphones. So note, receiver sensitivity with an non-zero IF receiver is around 30 dB. Non-zero IF receiver is not as sensitive because of increased noise at lower IFs caused by the flicker. So here what we are going to do, we are not taking the. So in non-zero IF, we are generating the IF frequency to eliminate the noises which are applied in the mixer filter. So another important thing in the CSWR is isolation between the transmitter and receiver. So this isolation is required when we are using both the transmitter and receiver single antenna. So isolation is provided between the transmitter and receiver with the following methods. So Doppler effect, circulator, hybrid junctions, separate polarization, separate antennas using a control signals. These are the different methods to isolate the transmitter and receiver. So the amount of isolation between transmitter and receiver depends upon the transmitter power, transmitter noise, ruggedness, sensitivity of the receiver. If the safe value of power which might be applied to the receiver were 10 milliwatts and if the transmitter power were 1 kilowatt, therefore between transmitter and receiver must be 15 dB. In practical devices have isolation of 20 to 50 dB. Examples: Crystal 40 to 60 dB, high gain antennas 80 dB, X band 50 dB, K band and 70 dB and L band is 20 dB. So this is about the isolation and non-zero IF of the amplifier. Non-zero IF of the